All right, you need to follow along on your scratch paper. If you don't have scratch paper, you need to get some now. Follow along with the math on the spot video. Let's get started.
I'm thinking about retiling my kitchen. But instead of using, regular, boring, square tiles, I'm thinking about maybe tiles that have different shapes. What do you think? Actually, you know what? This whole conversation that you and I are having, this is actually reminding me of a great math riddle where, in fact, there are crazily shaped tiles that make a really interesting pattern that can be used to tile. And in fact, we can actually figure out some areas. Let's take a look and see how we can see mathematics and areas even in tiles. A pattern used for tile floors is shown right here, kind of an interesting pattern. Now, a side of the inner square right here measures 10 centimeters, and a side of the outer square measures 30 centimeters. Here's the challenge. Can we figure out the area of just one of the yellow trapezoid tiles? Now, check it out. So what we have here is we have these four trapezoidal tiles, and then if they surround this blue square and together make this larger square. And the question is, can we find the area of one of these? Well, I'm going to show you a really sneaky way of finding it, and then let's actually check our answer by using the really interesting equation that gives us the area of a trapezoid. So we're going to do it twice real fast. Let me show you the real fast way. The fast way is to find the area of the entire square. Now remember, we know that this is 30 centimeters and this is 30 centimeters. Oops, but you gotta be able to write 30 the right way. So the area of the whole square, is length times width, so it's 30 times 30. 30 times 30 is 900. So we know the whole thing is 900. That's the whole thing, centimeters squared. But actually, we want to remove that little teeny square because that has no yellow in it at all. That's actually blue. And we know that length actually right here is 10, and this is 10. So this is a 10 by 10, 10, 10 by 10, 10 by 10, 10 by 10. And so the area of the blue part is 10 squared. 10 times 10 is 100. So if we subtract that away, that's only going to give us the yellow parts. That's 800 centimeters squared. But they're made up into four equal pieces, those trapezoids. So if we take 800 and divide it by 4, so divide up 800 by 4, we see, in fact, the answer, which is 200 centimeters squared. So let's just write that down here and say, okay, top secret, 200 centimeters squared is our guess. That's our guess. Now we'll see if we're right or not by actually using the kind of cool formulas that we've already been thinking about. But I just wanted to show you, you can be a little bit clever. It's never bad. Okay, so now let's take a look at a different way of looking at this. So let's now focus on just one of these individual trapezoids. Well, we know that the base, this bottom base, is 30, and we see that the top is 10. And if you remember now, how do you find the area of a trapezoid? Basically, what you're doing is you're going to kind of think of it like a rectangle, where you're going to kind of take the average of the top and the bottom and multiply it by the height. So basically, what we have here is this great formula, which says that the area is 1/2 the base of the length of the bottom plus the length of the top, so the bottom base, the top base, and you multiply by the height. And the way to think about that is, really, if you take that long length and that short length, and you average them, that's going to kind of give you the middle length, and if you multiply that by the height, it's like a rectangle. So this is kind of like the average of the bases, and you multiply that by the height. Okay, so let's try to do that. Well, so this is easy. We know that the B1 is going to be 30. So I'm going to write that down right now. So we have B1 is equal to 30, and B2 is the top part. That's going to equal 10. And now what about the height? Uh-oh, this is tricky, because what's that perpendicular height? This is really sneaky, but you have to remember this whole outside shape, remember, is a square. So this is 30, that means this is 30. And if that's 30, let me just draw this dotted line right here. So I'm going to draw this dotted line. I hope you're ready for this. This is a dotted line. I'm drawing a dotted line whether you're ready or not. Here we go. Well, that is 30. But we know that this part of the dotted line, that's part of the edge of the blue, is 10. So I know this is 10, and so what's left for everything else? So everything else, so this piece right here, and this piece right here, is going to be the difference between 30, the entire length, minus the 10, and that equals 20. So this length plus that length equals 20. But these lengths are the same because, in fact, it's the same shaped trapezoid that's all around. So this length and that length are the same, and they add to give 20. And so how could I find the length of just one of them? Well, I take half of 20. So if I take half of 20, that would give me 10. Aha! So this length right here is also 10. And we've just discovered that this is 10, which is the height. So the height is, in fact, 10. And so this height is 10. And so now what we have here is the following. We know that the bottom base is 30, that top base is 10, and now we just discovered that the height, which is the perpendicular height, is also 10. And now we can plug it into this formula. So great, here we go. We see that the area equals 1/2 times, well, we've got 30 plus 10, and that's all times 10. Now remember the orders of operation. We have to do what's inside the parentheses first. And so 30 plus 10 is 40. And now we go from left to right. And so 1/2 times 40, that's basically half of 40, which is 20. And 20 times 10 is 200 centimeters squared. And check it out. This actually gives us the answer. The area of each trapezoid is 200 square centimeters. But check out the fun part. Remember how we guessed that a long time ago? We now see that our guess was great, and we found the area. There are lots of ways of looking at different geometric shapes. You could see it as the whole minus a part and then dividing by 4, or you could realize that there are these wonderful formulas, these equations, that allow us to figure out the area of a trapezoid, just knowing the length of the bottom, the length of the top, and then the height, that perpendicular height, and you can actually use this formula. However you look at things in the real world, as long as you think about what you're seeing and make meaning of it, you will be able to use the equations and the formulas and the figures that we see around us in order to see it all in a richer way. Have fun seeing things in a richer way in computing areas. Trapezoids. I'll see you soon.
Thanks for watching. I'll see you on the next one.